So, Assalamualaikum warahmatullahi wabarakatuh. So, welcome again to our YouTube channel. So, for today, we're presenting our last topic and lab session. So, for this lab session is about AC high voltage measurement and monitoring. So, I will introduce my group members, which be the same, Azam Mulinda and Ashraf Raza. So, for the first question that been discussed is about how to assemble on how I assemble all the component that been doing in this lab. So firstly, so basically this lab is an addition from the previous lab too. So for this lab is an addition to the picoscope that will be the monitoring that we conducted on the PC. So from the picture that shown on the screen is it will be started from the CNB supply, and then will be goes to the FC frequency converter, and then it will be start up with using the transformer, and then the connection will be goes to the secondary AC unit, and from the secondary AC unit they will be doing by using the T junction that used to parallel the FC frequency converter and the picoscope. So from the picture that been drawn by me, so that is the assembling of the drawing that completely been done. So for the next person that will be discussing about section 2. So you can start it.
Okay, I'm Muhammad Ashraf. I will present about the configuring the procedure of setting the kit control and picoscope. Firstly, before the injection high voltage testing, we must set up all the parameter that need to set at the window of the kit control and the customer setup in the hardware. Firstly, in this experiment, configuring the procedure of setting the kit control is most important part before the injection to this equipment. The default setup of the kit control must follow the manual book by the manufacturing provide to our user of this equipment. The criteria of primary side of the transformer and secondary of the transformer of the equipment must be set up as followed as manual book. Moreover, the equipment that involved in this equipment is picoscope. The picoscope device need to set up by the customer setup window in the software. Before begin any injection of the system, the user need to aware and use protective tools such as a glove that protect the user from dangerous situation. I will share the point that I selected the most important parameter that need to set at the window. Number one is the source control. Number two is the alarm and the power on and off monitoring. The system monitor about the secondary unit, which is the add slot. Fourth is the reset button. 5 is the power power button and the shutdown button of the system. Next, the customer setup at the window. The first is the manual setup. Second is the impulse sequence setting for the impulse generated wave, and the calibration that we use for one port network for this hardware. And after calibrate the setting of the VM1 at the kit control, and we have to save the file that we need to run the simulation for the next step. And this is during the injection high voltage testing. This is the kit control procedure. Firstly, the source control of the kit control is being set up by focusing the default parameter and make sure the red alarm do not appear when the injection test is not begin. The red alarm represent the system is not ready to start because there has problem to the safety of the system, such as the door is not closed properly. The primary side of the transformer is represent the voltage and current that appear in the window of the source control. The result of the primary side of the transformer is easy to analyze and discuss the difference of the data. Next, I will highlight the serial number of the secondary transformer, which is the S/N 22341076-04, and the voltage divider ratio, which is 19651.1 volt, and the source of the control has 8 slot of the secondary transformer. Then I will go to the picoscope setting of the equipment. The most important part of the setting is when we do the data acquisition, that we need to set the 0 to 10k value, and next we have to analyze the data that can be analyzed in this screen, and we have to measure the RMS value, the VRMC value for the capacitor, V peak, min, VM, V peak, frequency, PhD, and the driving factor. And next, that's all for me. I will pass to the next
So
presenter.
before we go to Azam Melinda, Ashraf, can you scroll down, scroll up for the first question back?
Okay, I will go to your part.
Yes, there is something that I just passed by.
Okay.
So scroll up a little bit on the question.
On the question, okay. So say.
So
Can you see?
so I forgot to mention about the how can I suggest for the safety rule that needed to be concerned on the earthing switching and clean testing layout. So from the video by Zikri, that he had teach us how to be aware about the earthing switch must be touched properly at the top of the electrode. So at the top of electrode, and there is a earthing switch. So we must double check on the earthing switching that must be properly touched at the top of the electrode. So for the next things that we have to precaution is about how to manage the wire that been assembled around the lab. So we must to manage to clean up the wire that been assembled correctly. So to prevent hazardous and risk happen around the lab. So Azam Brinda will continue for the third section.
Okay.
Okay, thank you, Sajani. So this section is my part, which is the question is asked me to make a comparison between the value of kit control, which is as our reference, and then the value of picoscope. So basically, Chak, can you scroll down a bit just for the table?
Okay, can you see?
Yeah. Okay, for as you can see, so the voltage output, which is the Ashraf already mentioned, which is the symbol that the in the video that Sir Zikri named it like private inspector and sergeant. So that one is the once we click the private just like 0.01 or inspector we click that one will be 1, and then the sergeant is 1 click per 10 per 1 click. So as you can see here, kit control is a little bit high than picoscope, and then the next is the error, which is the calculation for error is the kit control value minus picoscope divide by kit control and then time with 100%. So you will get the error percent, and then the frequency we use is fixed, which is 50 Hertz. At the table below, you can see the kit control peak value, peak over set, which is the value is in the calibration file that Suzikri give. That one is the value in the kit control is in milliwatt, and the picoscope in the kilowatt. So in between, after we made the calculation for error, just because of the play with the milli and kilowatt, we can see the error is quite high, which is the for example for output voltage 4.3, the error is 1.12 mega%. And then also same like previous, just use the frequency for 15 Hertz. Okay, Chak. Can you scroll more?
Okay, you can see.
For the conclusion. Okay. Thank you. Okay, for the conclusion, the discrepancy between the kit control and picoscope mostly is because of harmonic. There is the harmonic can distort the value of the value or the reading of the equipment. Whereas the picoscope is more visually displayed waveform to reveal signal strength, wave shape, and the instantaneous value of the signal. And then also because of the sensitivity of the measurement device, besides that, basically this setting is used 100,000 sample, whereas the wave is more narrow, more smooth and very detailed wave, and then the less sample is become expand like we zoom the wave. But if we click the graph, they have a graph on the wave, and then the more we click the voltage output, the more high the amplitude of current at the picoscope, and getting high the wave of voltage at the kit control. For the last part, where is the voltage output is reducing to 0, but the both reading still in high voltage, which is the remaining charge is still there. So the method to discharge the voltage inside is need the discharge rod, where is the rod is connected to the ground. After that, all the equipment is safely to touch after we discharge by using the discharge rod. Okay, that's all for us. So thank you.
So thank you everyone for participating for our last lab. So so that's all for us. So thank you.
Thank you.
Assalamualaikum.